Hi guys, I'm Yuyue. I'm a senior student of NYU Shanghai. I major in neuroscience and minor in data science. Here I will present you with my DERF project on a neuroeconomic topic, the mechanism comparison between different timescales of human discounting behavior. So what is delay discounting behavior? Literally, it is the behavior that human would discount future or delayed reward. For example, how do you feel about 50 RMB today and 50 RMB after a week? Which one would you prefer? So of course, in this case, you would prefer 50 RMB today because we think that I'm waiting for that long time. So 50 RMB after a week, it kind of feels like a little bit less than 50 RMB today. So that's when you discount it. So this is called delay discounting behavior. So this kind of behavior has been studied by many neuroscientists over the years. So there are two main methodologies when people are studying this behavior. One is the long verbal delay. So this is mostly done on human. In terms of long verbal, it means that the delay duration is relatively long, from days to weeks up to months or even years. Verbal is because there is normally verbal instructions during the experiment for the human. Here is an example of a long verbal delay task. It's done by Boss in 2014, and we can see from these figures that he's making his subjects to choose from $10 in 0 days or $27 in 28 days. So you can see there are verbal instructions here. You can see those words, and the delay time is like 28 days, 21 days, 7 days. So this is a typical kind of long delay. So another kind of methodology is short nonverbal delay. So compared to long verbal delay, the delay duration in this kind of experiments are usually very short, within a minute. Often it's like 1 second, 2 seconds, normally won't be longer than a minute because it's done on animals like rodents. So animals won't wait that long. They would think that something goes wrong. Also because it's done on animals, there cannot be verbal because they don't understand. So it's nonverbal. The rodents have to be trained before they can do real tasks. There are not so many this kind of short nonverbal delay tasks done in human. Here is an example. So this is an experiment done by McClure team in 2007. It's done on human beings, but the delay time is quite short. You can see from this figure that the subjects are choosing between 2 squirts of juice this minute or 3 squirts of juice after 5 minutes. It's still verbal, but the waiting time is kind of short for human. And what's special about this one is that normally we're giving human subjects money as reward, but in this experiment, McClure is giving subjects juice as reward, like giving juice to rodents. However, after researching among literatures, we found out there isn't much nonverbal delay tasks done on human subjects. There's almost no comparison between these two kind of methodologies done on human beings. So what we want to do is to do both long verbal delay and short nonverbal delay on human subjects, and we will compare their behavior patterns by analyzing their data. So to do these experiments, we're going to use computer programs and let subjects play games. The general procedure of our project would be, first we start with literature study to get a knowledge of the background of this field, and then we will do task programming, in which we will do coding, we will test the code, debugging, things like that, and then we will run experiments on subjects that we recruited. So, and after the experiments, we will do data analysis. So now we are still running the experiments now. Yes, our project is not done yet. It's still ongoing. So in this video, I will just show you what we have done so far. This program is called CyclePy. It uses Python to write codes, and it runs the code and will show the experiment you coded to the participants. So here is some main parts of our experiments. For example, learning stage is when participants learn the rules of our experiments. This is for nonverbal tasks. Remember that they won't be given any verbal instructions, so they have to figure out the rules of the game themselves during learning stages. This is similar to what's done for animals. So there are 5, or actually 6, stage 0 to stage 5 for learning stage, and those are written in separate files. Like this is file stage 0, stage 1. By the way, before learning stage, we'll run this white noise file for them to test the voice, because there will be sound stimuli in our experiment, and to make sure the sound is proper for the participants. So we'll run this first. After the participants see this thing and they press enter, there'll be a white noise. So this is the loudest sound that participant will hear during the whole experiment. So we let them to adjust the volume themselves, and if they're comfortable with this voice, just to press enter again. So now the sound has been set. Next, we can run our learning stages. So they will type in their night ID, which has already been recorded in our database. Net ID, and start the learning stage. So if you explore what to do, you may get a violation. So if you click here, there's a coin. So yeah, you passed the stage 0 of learning stage. Next, you see something else. Here, I will show you our verbal test, which is quite similar after you see those nonverbal tests, that actually they're much more obvious and direct. The participant would know what to choose at the first glance. Let's have a look. Same, you put in your net ID, and you see the verbal instruction. You click on it, and you will have to choose between 10 points now or 50 points in 2 seconds. So select your points. I got 50 seconds. Sorry, that's loud. 100 points. That's basically the same, but obviously you know what we want you. So after each block, you will have a 20-second break. And yeah, now we make the number of trials in each block pretty small because we need to demonstrate it, otherwise it takes too long. So stop it and enter the second block. So here is the analysis of our experiment done on August 26. There were only 4 participants on that day, so I will go over some of our analysis for that experiment. Since basically we did this experiment as our pilot test to see whether there is something else that we still need to change about our code, and if there's some logic that is not quite making sense. So yeah, the result is quite simple. And here, for each stage, RT is the reaction time. We propose that the reaction time should decrease as the trial state go. So it seems like from these graphs, it looks like it's going down. So like the more trials they do, the fast they relax. Yeah, that's pretty good result. It is presented in this slide that the stage for reaction time versus the reward. Intuitively, the greater the reward, the shorter the reaction time. Like imagine there are two choices in front of you. One is to choose 10 RMB for now, the other is to choose 10 RMB after 10 seconds. And the other choice is to choose between 10 RMB for now and 50 RMB after 10 seconds. It should take you much less time to make the decision of picking 50 RMB after 10 seconds compared to 10 RMB after 10 seconds. For this participant, the reaction time decreases. For this one also, for this one is almost like the same, but for this one it's a little bit weird. From the feedback we got from those participants, they seem not have learned what we want them to learn. But essentially, we don't have something that must be learned by them. They can understand the task in their own way as long as they can make the decision. So we cannot really say much about it. Since we did make many changes according to the result we got from this experiment session. So yeah, this is just for reference, and we'll have more analysis later on. So this is our GitLab page for the whole lab. And these are all the CyclePy code we've done so far. This GitLab is a really good tool for us to upload and download our own codes and others' codes, because it can save your history so that you can always trace back to maybe the previous version of your code. So here is my SQL, that's the database of our experiments. It's pretty easy to get the information of other participants and each of every steps during the experiment. For example, so here we can have a look at those experiments are run on September 3rd, and this is their learning stages, and this is their mixed nonverbal. Here we can see their total profit, and we're paying them in an exchange rate of 10 points equal 1 RMB. On the day of the experiment, before the participants started the learning stage, we will give them this survey to fill out, to have their demographic information of like nationalities and their first language, their class, major, for convenience of our further data analysis. And after the experiment, we'll give them this feedback form to let them give us some comments and suggestions of our experiments, so that we will know what the participants thought about our experiment. Is it too hard? Did they learn something? Was the delay too long? And how was the payment for them? Like everything we want to know. So this is our behavior lab in Pudong campus. We have 6 rows and 5 PCs in each row. The lab is also equipped with whiteboards and projectors on which we can give instructions to the subjects. So here we have a closer look at one row. Each 2 adjacent participants are isolated by partitions so that they won't disturb or influence each other. We have wireless mouse connected to each PC, and we bought 6 headphones using my DERF budget. So this is what the subject will see when he or she first comes to the lab. Presented on the table are the subject's copy of statement to subject, experiment instructions, and consent form. They need to sign the consent form and read through the instructions before they start the experiment. And finally, this is our inventory for subject payments and the procedure of an experiment session. So that's basically what I've done for the DERF program during the summer. It's still not done yet, and I will enroll in an independent study course this semester to continue on this project. It was really a fun experience to work with Professor Jeff Ehrlich and the postdoc Jania, and I really learned a lot during this summer. I really appreciate this chance provided by DERF program for me to do research. Thank you very much for watching this video.